Good afternoon, everyone, and welcome back to the Greenstat Asia webinar series. My name is Prasadini Wickramasinghe, and I work as an energy analyst while also coordinating Greenstat activities here in Sri Lanka. It is truly wonderful to see many of you joining us today from across the region. Thank you very much for taking the time to be here with us. Today's session focuses on turning waste into energy, practical biomethane production insights. As many of you know, biomethane is increasingly gaining attention as a practical solution for both sustainable waste management and renewable energy production, particularly as countries seek scalable pathways to reduce emissions while strengthening circular economy. Before we begin, let me briefly introduce who we are. Greenstat Asia is a clean energy consulting company dedicated to accelerating the transition towards renewable energy with a strong focus on green hydrogen and sustainable energy solutions. Through the Greenstat Center of Excellence for Hydrogen, we focus on knowledge sharing, capacity building, and international collaboration. We work closely with universities, government institutions, industry partners, and global experts to advance renewable technologies, standards, policy frameworks, and the entire value chain. Our goal is to support emerging markets in building strong, future-ready clean energy ecosystems. It is now my great pleasure to introduce today's speaker. We are very pleased to have Mr. Evald Pärni, Regional Sales Director at Biovoima. Evald is an experienced international business and management professional currently working with Biovoima, a company specializing in biomethane upgrading technologies and renewable gas solutions. Over the course of his career, he has held management and business development roles in several leading multinational companies. There, he gained extensive experience in international markets and strategic business development. Evald holds a technology engineering and degree from Evald University of Technology, one of the leading technical university in the Baltic region. Through his work today, he focuses on supporting organizations in business development, market expansion, and the development of sustainable renewable gas solutions, particularly within the biomethane sector. Before we begin the session, we have some housekeeping rules. Please feel to type your questions in the Q&A box at any time during the presentation. We will address your questions during the Q&A session towards the end of the webinar. A recording of the webinar will be shared with all registered participants in the coming weeks. Evald, the floor is yours.
Okay. Thank you. Nice to have here. And when you go to the today's topic, well, before I go to the today's topic, so can you see? It's coming. Yep. And before we go to the today's topic, I will tell you a few words about the company. What is Biovoima, from where we are coming, what we are doing, so you understand. So what is our background and why we claim that we know we can advise you or can help you. The Biovoima is a Finnish company established in 2014. It's a privately owned company, and the headquarters is located in Finland. So Jyväskylä, it's about 300 kilometers up from the capital. And we have a team close to the 40 people located in 5 countries, Finland, Estonia, Lithuania, Poland, Norway. So let's say the northern part of Europe, we look at plus our home market, but we also do business globally. And basically we have right now a few quite the big projects ongoing, our developments ongoing in Asia also. Our turnover last year was about around 20 millions, and this year, if we are lucky, we double, but at least we want to increase it by 50%. And we have completed about 30% 30 projects internationally. So what we do, what we do is actually we have three pillars of our business, which means that there are technologies, uh, what we produce by ourselves or combine with our partners. Then we do the turnkey projects. They could be greenfield, which mean that we build a plant from ground zero, or then they could be, we call them brownfields, that like if you have the biogas production, we can help you upgrade to the biomethane production, or if you have biomethane production, we can help to add some kind of grid injection on transport solution. And if quick turn about technologies, so we have bio upgrade, which is actually membrane cleaning. I will tell about that a bit later. So we do that by ourselves. Then we have bio adapter, which is a unit needed for the grid injection. There is usually some kind of measuring gadget inside, chromatograph, which measure the quality, and there is often also the pressure reduction, or depending from the grid, there could be added also the compressor. The biologistics is actually the transportation solution with the containers. There are different vessels, could be um, steel vessels, which are cheaper, or there could be composite vessels that are more expensive, but you can transport more. The pasteurizer is the sludge heat exchanger. It's needed for the pasteurization. And why pasteurization is needed, I will tell a bit later. Obviously, then we have service, we have filling solution, and now we have developed now also our own CO2 liquefaction solution. And maybe something what we have done in Finland, we have done a biogas plant for the water treatment company using sewage sludge, making from that the biogas for their own needs. Sometimes they also use the oil from the companies if they can get to make that more production. Then in Estonia we have built a plant which is working purely on the bio waste, which means the bio waste coming from the households and bio waste coming from the businesses. And now happens something. Sorry. And then we have now just finishing one plant in Norway, and this is interesting plant because it's combined bio waste and manure. So they both are coming from the area of about 100 kilometers, and then we collected there and making biomethane, which is used in the business for the business purposes. The production companies are using that, and also the transportation. As I didn't know what is really the level of the knowledge of the biogas and biomethane, I just put there some basics to understand that, because usually people say that it's biogas, but actually biogas is a mixture of the methane, CO2, and small quantities of the other gases. This is what coming up after digestion. It's coming up anaerobic digestion, and then if you clean it or upgrade, as we say, so then you get the biomethane, which is actually the same as a normal methane or natural gas, what is coming out. And actually cars are not running on the biogas, but they're actually running on the biomethane. So this is the difference. Because why actually to use the biogas? Obviously, that is the one of the best ways, sustainable way to manage the large organic waste streams. It's a big problem in the world. And then conversion that waste to the energy, which is at the moment, as we know what's going on in the world, it's very important. And then also with the reduction of the dependence of the fossil fuels, so you have your own emergency or daily supply. And then also the landfills place, because in number of countries are the huge areas under the landfill, and that's a huge problem. With that, as you reuse the bio waste to generate energy, you can reduce the landfill space needed. And then also local value retention. You make the locally jobs. There will be, I don't know, so that kind of stuff, and the money is staking on it stays on the area. I think it's quite important. And that's why we say that you just not having the biological waste, you actually managing energy asset. What is something to think about it, because normally people don't maybe look at that way. And if you look what all we can basically use all biological waste, whatever it is manure or wastewater sludge or food waste or some other organics, whatever they are. So we can all that digestate and make from that the biogas. And biogas, actually, I will tell you, biogas you can use directly to produce heat and electricity, or then you can upgrade it and then other inject to the grid, make it vehicle fuel, maybe some other needs what are on the businesses. And then also that if you use the food waste, then usually you have the plastic reject, and you can reuse the plastic reject to produce the new plastic projects. And then digestate. This is what is left after the process. You can use as a fertilizer. If you separate it, the solid part you can use as animal bedding, or you can bag it and sell it on the hardware stores or somewhere where sold where you're selling the fertilizers or soil, and then also other products. So there is a lot of way to use, lot of what you can get out from the waste. And basically, if you look at the process is the starting is the same. You have waste collection. Waste collection obviously depends what kind of waste. Then you have pre-treatment, and pre-treatment vary because if you look at the food waste, so then pre-treatment is more complicated, obviously more expensive, unfortunately. Then if you look at the agricultural waste, for example, so their pre-treatment is much easier. And then it goes to the anaerobic digestion, and then biogas you can directly biogas can go to a CHP, which is basically big engine where you can make heat and electricity, or then you upgrade the biogas and clean it. We'll tell about more later, and then you can inject the biomethane to the grid or use it as a fuel or liquefy it, and also from that after upgrade you can also produce liquefied CO2. In some countries, it's becoming a big business because it's needed for the hydrogen production, but also there's some businesses it needed. You can upgrade to the food grade, it can go to the hospitals, it can go to the farms, the greenhouses needed, or what industry is needed. So sometimes we have funny things that people think that CO2, what is produced for manure, there is something bad. You cannot use it on the food industry, but it's just a gas. So it's actually nothing to do that, but well, people are different. And then now we're looking the same what I just showed to you in the maybe real life picture. So here is a pre-treatment, the reception hall. It's quite a big one because we are talking about the bio waste, and I will show a bit later also the movie about that. And then it goes to the digestion, because here we have the reactor, what we call plug flow reactor. And the benefit is that you can use their material where the dry matter content is up to 20%. Because if you go to the wet digestion, it's 15%, and then gas reduction is bigger. And here is also that its material is moving through that to the post digester, and it stays there about totally in 43 days. And then after that material is going to the digestate, is going to the separation where solids are separated, sold as a fertilizer, and liquid is going back to the storage tank and partly used in the process. And this liquid fraction could be also used as fertilizer. And the gas obviously is going to the upgrading. Here is a small upgrading unit. So it's called PSA, and it's upgrading the biomethane, and then biomethane is either either from that small container, there is a grid injection unit, it's injected to the grid, or then here is actually, the picture is a bit small, but here is actually also the possibility to fill the trucks, because the company, this waste management company who is running that business, they also have waste trucks running on the biomethane. And then obviously, as you see here, is this CNG container, and this is taking the gas to the city bus terminal, where city buses are using the biomethane. I think in that city called Tallinn is about 450 biomethane buses on the city, so they are very much on that. And then let's see that same thing in the picture what I just told you. So that was visual about that, and if you notice in the start, so there was a very big hole for the reception and treatment, and that's the thing what you need to have with the food waste. And now we are going to the, let's say, to the maybe topic of the day. So we're talking about the upgrading technologies and what are practical consideration when you go to the upgrading. So let's start. Basically, there is a number of upgrading technologies available, but we mainly recommend and use the free one. One is membrane upgrading, what is here presented. And logic of that is just basically there is a lot of small plastic tubes. They are like spaghettis, that kind of, but they are membranes actually. And gas is pushed under the pressure in and to the membrane, the smaller molecules of CO2, O2, H2S, and water are coming through those small walls, and CH4 as a big molecule is going just through. And in real life, they look like this. So this is probably one of the maybe cheapest way to upgrade the biogas and to clean it. The other thing is PSA. PSA cost more, and basically, if you look the size of the plant, so then probably membranes you can go with quite small production up to 100 cubic centimeters per hour. With PSA, the minimum is 500, and PSA cost more. But the logic of the PSA cleaning is there are molecular sieves inside the vessel. So then basically, then gas is pushed through on the pressure, and those sieves they capture H2S, CO2, and water, and biomethane is going through and going to the storage vessel. And then if one vessel is full, so then they switch to the next vessel, and then vacuum is sucking out CO2 and other gases from that vessel. So it works like this way. The good thing with that is that it consumes about 30% less electricity than a membrane. But again, it's more technical, it's more complicated to serve, and it costs more, about maybe up to 40%. It depends a bit. And then if you thinking to start producing biomethane, first things you have to think is what to use, what kind of technology to use. First thing is the size of the plant. So different technologies are suitable for different sizes. If you have small plants, basically there are two things: membrane separation or water scrubbing. In some countries, water scrubbing is popular, but the thing is the water. You need a lot of water. Even you can recycle that water, but still that's sort of in a number of countries that's no go. And then medium-sized plants, then the PSA, what I just tell you, and the membrane system. So both of them are excellent for the medium scale plant. Large scale plant, same PSA, same membrane, but also chemical absorption. scrubbing. Scrubbing is very good. You can get very, very clean biomethane from that, but you need quite a big production plant to make that economical, because there is a lot of operational cost involved. And then, obviously, one big thing is operational cost or energy consumption, because upgrading requires usually gas compression, which means that you have to have compressor, which use energy. And then you need to pump the solvents in or generation of absorbents in amine scrubbing, for example. So that's why it's again going to the Excel, thinking what is more important for me, OPEX or CAPEX, or to be somewhere in between of that. And for example, if you look the membrane separation, it's moderator energy. Same with water scrubbing. PSA has about 30% lower energy need than membrane separation, but then again, it costs more. And then chemical scrubbing, very good for the very big plants, but again, a lot of energy is needed. One is for especially for regeneration, because there should be temperature up to 140 degrees. And then you shouldn't forget that everything should be operated and maintained. So you have to consider what is the complexity of the system. Can you have skilled people for that, or you train the people? So how long that takes time? Because usually we say that the best people to do that are people who have been some kind of process production, because this is actually the process, the production of the biomethane. If you go from the scratch, and even more difficult process, because there is the biological part is involved. And then obviously, what is the maintenance frequency? How much it costs, and what is spare parts availability? How easy you can get them, or you should calculate that I have the certain stock for the spare parts, but just cost money because they are laying on your shelf. You're waiting your time. For example, membranes are quite simple, not too much maintenance. PSA is moderate complexity, but again, quite easy. And chemical scrubbing, obviously, because high temperature and chemicals are involved, they need a higher operational control and more skilled workforce. Then you have to consider methane slip. Methane slip is a loss of the methane, because almost no processes. Okay, chemical scrubbing has very low, almost zero methane loss, but all the other have the methane loss. Even though they are a small percentage, is 0.5 for the membrane, PSA 0.5 to 1, water scrubbing 1 to 2, but it's still money what you are losing, because it's going out from the system with a CO2 and H2S, so it's something to consider, and especially when you have bigger production. So then 1% or 2% by the end of the day could be quite a lot of money. Something to consider again. And then, as we already mentioned, water and chemical scrubbing. So then the consumption of those materials, because in some area water is not so easily available. Because, for example, water scrubbing used to be very popular in the United States, because they don't have issues with that. And then chemical scrubbing requires chemicals. One thing, they are dangerous. Other thing is that also the availability of the chemicals and the cost of the chemicals, because there are a bit different chemicals what could be used. So that is something what you have to consider. So they influence also all those things influence in your technology selection. And then also the capital and operational cost. What is where is your what is your strategy to find some kind of balance, or more focused at as low capex as is possible, or as low opex what is possible? Because I have seen different approaches in different markets and by different entrepreneurs. In some markets, very mature markets, they say, no, to build the best what we can, we want to have the as low opex as is possible. In other markets, they say, no, let's save from there, and they even try to build something by themselves, and there are issues then, but then they try to bring the capex down. And then obviously, what is your local energy cost and the maintenance cost in the area? How much that influence on your business? So, for example, the membranes have low capex. Chemical scrubber have again high opex because energy consumption is very high. And as you mentioned before, for example, even PSA has even lower capex than PSA is higher capex but lower opex. So those are things. It seems to be a lot of things to figure out, but how we usually work is that if there is the projects, so obviously we make calculations with our team and will offer the client solutions. Hey, we think that this is best to you, but obviously if you want to, I don't know, emphasize capex or opex, so then this is the option. So what you prefer. So you don't have to stay there, I don't know, several months and thinking all those, how I put all that puzzle together. No, we can do that for you. And that was very quickly about the upgrading, because it's a huge topic, and you know that we can spend a lot of time there. And if you look at viability and commercial and market drivers, so basically where you can make money, you can make money by selling gas or biogas or really biomethane actually. And the easiest thing is to sell it to the grid. Then you can have also to compress it, like CNG, and sell it in container to somewhere. That's the compression is a bit more expensive part. We call that actually virtual pipeline. It's a bit more expensive because you need to have extra compressor which compress the gas to the CNG container, because there is needed the pressure up to 250 bars. And then you can liquefy it and sell that as LNG. As you know, that Qatar used to be a huge LNG seller, and now there are some issues. So if you have LNG on your own backyard where you are producing it, it's very handy right now. And then there is the big business are also the environmental credits, because you as I know that you guys are from the different countries. So in some countries this is a business, in some countries is not business, and you can sell those certificates and the carbon credits. That's quite a big business in Europe. And then obviously, if you are a waste management company and taking in bio waste, you can use money by getting additional money from the gate fee. And then at the end of the process is coming out the digestate. You can sell the digestate because digestate is actually the fertilizer, and very good fertilizer. And compared to the like manure, the good thing is it's not smelling. So you can make money from that. And then also you can liquefy CO2, and where is the market for the liquefied CO2, you can also make good money with that. So then basically everything but coming out you can sell. So it's quite a good business. And maybe I'm looking now that maybe going a bit more details, but then in the countries where are the carbonization targets and then the prices, the carbon prices and what affecting the price of the gas, and then also then our corporate goals, especially with ESG, which means the environmental, social, and governance goals. So companies try to be green ones. So that affect all the price. And for example, in Europe, the highest price to get from the biomethane produced from the cow manure, because in a way it's a fertilizer already, but in a way it's the issue, especially right now there are big farms and there's a lot of manure and there is nowhere to put it or transport in the reasonable way, plus their smell. And energy security right now, very hot topic because it reduce reliance on the fossil gas, on the fossil energy actually, and that helping right now a lot. And what happens in the future we don't know, but it's very good to have that kind of production at your backyard. And then obviously again taking down the local waste quantities. So you making from the waste you do actually fertilizer and the energy. And then market transportation is going up because for others says the transportation they're using bio LNG. Actually there are the ferries. So it's much more environmental friendly than going to that kind of oil, but they're using right now for the ships and the buses and trucks also to make your city environment much more much nicer, much more friendly, no smells in comparison to the diesel buses. And with electricity, yeah, good question, because what I know from the company who is running a lot of buses, the bus company told me that the easiest to serve are diesel buses, then the gas, and then electricity is most complicated. So how you take it, and then obviously there is a lot of political issues and preferences, but it's very good for the environment, and also if you are your own production, you are not reliable about the gas prices outside and what the gas companies are doing. You just have producing your own fuel, and then just again mention about corporate sustainability programs. They want a green one because even, for example, in Europe, a lot of data centers, they want to have green biomethane, what they use for the energy to produce their energy because they want to be environmental friendly. And then obviously again, once more, the driver is the waste management, waste challenge, because the amount of bio waste in the world is growing, it's growing a lot, and then you have to do something with that. And then yes, one way is just to burn it, but we think that producing biomethane is much more better because you can not only just because you burn it, you get the energy, but you can use electricity or heat. But then here you can have also fuel and then fertilizer. And if you look the return of investment on biomethane projects, so there are different, a bit different, but still we are talking in average 20% because it depends what you do. Why is different on agricultural projects? The return of investment and food waste is because food waste from the same amount, let's say 1 kilo from the food waste, you can produce much more biogas because the dry matter content is much higher than from agricultural products as average. So this is about 20%. Obviously, if there is the countries where government is coming in and helping with subsidies and supports, so those figures could be much higher, and it could be much more lucrative. And obviously, there is a different forecast. Somebody will say that in 3 years, global market will be up to 5 billion. Somebody say that in 4 years, if that will be very much focus on that, it could be even 60 billions. But anyway, it's the way their companies and countries are going. And at the moment, obviously, Europe is one of the leading one because we're about 50% of the total production is in Europe. It has also a lot to do with the big countries like Germany, because let's say almost every German farm has a biogas production. They're using the energy just to produce electricity and heat, and not to buy it from the grid because it costs more, and then they get rid also from them for the manure. And if you have to integrate the production or how you get the gas to the buyer. So there is two ways actually. So one is the direct connection to the grid, to the pipeline, and the other is what we call virtual pipeline, which means that you compress the biomethane to the CNG container and then send the container to somewhere where it will be when it will be offloaded. So and the grid connection unit is basically it's simple in a way, but it's quite expensive because usually it means, well, it depends again country and the demands of the grid operator, because standard is that you need there at least a chromatograph, which is looking all the gas, monitoring the quality constantly, because it's going to the grid where is natural gas, and there are some components, especially oxygen, what they are really looking after, and then obviously you have a pressure reduction unit, or if you have very high pressure grid, and then you probably have to have a compressor after the container that kind of grid injection unit, or then there is, if you use that, you can use it to the offload the CNG container. So then you need also the heating units, because if you offload the gas from the 250 bars, so it gets very, very cold. So basically, this is that kind of gadget what you needed to get to the grid. In some countries, it's more technical, which means also more expensive. In some countries, it's easier and it's cheaper. And obviously, they are fully automatic systems. You can monitor and adjust them from the distance. So from that point of view, they are very high-tech systems. And once more, we are almost finished. But then if you take that all together, what are the key benefits of the biogas or biomethane investment? So then waste. We turn the clean energy to the waste. We clone the clean energy to the waste, and we get rid of that. And then obviously we can have own fuel. We are independent for the fuel companies, the pricing strategy, and then we can improve energy security of the country. Then financial returns and operational savings. It reduces landfill and fuel cost if you use that and don't have to take the bio waste, for example, to the landfill. And obviously you have new business, new revenue stream, selling energy and selling fertilizer, and as I mentioned already, less dependence on the fuel. And then cutting greenhouse gas emissions, and then making more local businesses, local job, local infrastructure. But that's all from me. Thank you.